How do you find the distance between 2 points? Sometimes they're going to be given a graph like what we see here on the left. They will actually connect the 2 points with a line. Sometimes they won't, so it might be just 2 points sitting there. And it's up to you to find out what's the distance between them. Or instead of giving you a graph, they'll come over here and they'll give you just the coordinates with no graph and they expect you to do the same. What's the distance between these 2 points? So let's start with the graph first. What I recommend is that you actually sketch out a right triangle. The distance between the 2 points that you want should be the hypotenuse. And then you can use like the rise over run and slope to find um, a right triangle and use it to get the length of each leg. So that length there on that leg highlighted would be 4. The length of this leg would be 4. And then you're free to go plug these values into the Pythagorean theorem. Since we have both legs, it's pretty straightforward. And we'd have 32 equals c squared. Well, that means we have to find the square root of 32 to find c. If you want to find the estimated distance, it'd be 5.7 if you rounded. If you want the exact distance, basically go and simplify radical 32 or square root of 32 to 4 radical 2. If we have the distance between m and n is what we need to find right there, go make your triangle, find the length of each leg, plug that information into your Pythagorean theorem. Here you see we get the square root of 80 is what we need. And so that would round to be about 8.9, or if we wanted the exact distance without rounding, we would say 4 radical 5, because that's the square root of 80 simplified. So that's pretty straightforward. I think this is the part where it causes more people problems. They start to shut down when they're already tired on a test. But hey, remember when we said we made that right triangle basically using the rise over run, the slope in other words. So how would we find slope from two coordinates? It would be y minus y and x minus x. So if you find the difference of the y's and the difference of the x's, you've got your legs. So let's go find the difference of the y's. That'd be 2 minus 4. And the difference of the x's would be 4 minus negative 3. As you can see, I've got my y's on top right here, and that's very much like our y minus y. We've also got our x's right here, and that's very much like our x minus x there in the formula. Well, 2 minus 4 is negative 2. 4 minus negative 3 is 7. What do we do when we get a negative number for a leg? Well, just use the absolute value. How far is negative 2 from 0? Well, it's 2. So use the absolute value, make that like a positive 2. And now we can use this as A, and we can use this one as B. And from this point on, I'm not going to keep writing in that positive 2 there. We can now just throw these values into our Pythagorean theorem. And the square root of 53 cannot be simplified, but if we estimated, it'd be about 7.3 rounded. So that's the distance. Now, I'd like to take just a moment to prove to you that finding the difference of the y's and x's really does work on getting you your leg values. So let's take these 2 points right here and put them on this coordinate plane. If you made your triangle, the first thing you'd see is that from here to here would be 2, and from here to here would be 7, and that was the same leg distances that we found, subtracting the y's and the x's, and as you can see, when we put them into the Pythagorean theorem, we get the exact same answer. So it really does work. Subtract your y's to get one leg, subtract your x's to get the other leg, and then you'll be able to plug them into the formula, Pythagorean theorem, to get your distance.